4 more circle facts today. 4 more circle facts. These facts tomorrow will be going into the reasons column of proofs. We haven't had a proof since Unit 7, and this is Unit 10, so they're coming back, whether we like it or not. All right, we'll have a big celebration tomorrow before we do our reunion with one. All right, but they are coming back tomorrow in class. All right, we're ready to go. Here we go. First circle theorem today. First circle theorem. I need everyone to put circle O here, please. Circle O. And can you draw yourself central angle AOC for me? In your circle, draw a central angle AOC. I don't care how you draw it. Just make it a central angle AOC. Make a second central angle in the same circle, BOC. That looks pretty much congruent to AOC. So make a second central angle BOC for me. I know this has been a while since we've done this. How do I show the two are congruent? I know it's been a couple units. How do I show two angles congruent? Arc marks, right? Yeah. So let's show them they're congruent. Here's the first theorem, number 1. If the central angles are congruent, so are the arcs across from them. All right. So under number 1, here's what we're going to write. If angle AOC is congruent to angle BOC, then the arcs are congruent. Arc AC, remember our arc symbol? Congruent to arc BC. If the angles are equal, so are the darn arcs. There's theorem number 1. And we're not going to write anything under theorem 2 because theorem 2 is the reverse. If I give you the arcs are equal, so are the central angles. All right? Not too bad? All right? Central angles are congruent, so are the arcs across from them. All good? There's theorem 1. Theorem 2. I'm going to go through these a little quicker than I probably should, but I want to get to the application part. Do me a favor. We got circle O again. I know I'm being creative. Circle O. Can you please draw in chord AB somewhere in that circle? Chord AB somewhere in that circle. Could you also draw in chord CD somewhere in the same circle and make them look congruent? All right, make AB and CD look congruent. I don't care where you put them, but make them look congruent. What do I put on these to show they're congruent? Hash. You can see hash marks. Or like we're in the library teaching here. If the chords are congruent, so are the arcs. Okay, if the chords are congruent, so are the arcs that they form. So under number 1, if AB congruent to CD, then arc AB and arc CD are congruent. I went pretty hardcore on that last arc there. So if the central angles are equal, so are the arcs, and if the chords are equal, so are the arcs. There's 2 down, 2 to go. Any questions on these 2? All right, no drawing needed for the next one. I did it for you. If two chords are the same distance from the center, remember this fancy word we used to use back in the day? How do you say that? Equidistant, right? Equidistant. If 2 chords are the same distance, equidistant from the center, they're congruent. So we see how chord DE and chord CB are 8 units away. They're congruent to each other. So if two chords are the same distance from the center, they're going to be congruent. All right. I don't need anything. I'm not going to have you guys write anything underneath. All right. They're congruent. So chords equidistant from the center are congruent. 3 down, 1 more to go. Probably the most important one we're going to do today. I left it blank there too. Everyone draw circle O again. Circle O. Diameter AB. Diameter AB. Chord CD that looks perpendicular to diameter AB. So draw yourself chord CD, make it look perpendicular. Forms a right angle to AB. And how can you show it's perpendicular? Hasn't been that long. Right angle symbol. And put a intersection point. E, I guess. You want to put intersection point? E, where the chord and the diameter meet. All right, here you go. Here's the theorem. This is huge. If I have a diameter perpendicular to a chord, everyone, yes, diameter perpendicular to a chord, the chord gets, remember that word, bisected. If I have a diameter perpendicular to the chord gets bisected. Name 2 segments that are congruent now. CE congruent to ED. There you go. The diameter doesn't get bisected, it's the chord that gets bisected. So if I have a diameter perpendicular to a chord, the chord gets bisected. Time out. It is going to be very rare that you see in your diagram a full diameter. A full diameter. You may see this. What am I showing right here from O to B? That's called a what? Radius. Do you think the theorem still applies? Yeah. Yeah, it still does. You may even see less. I can't. Going to cover that up. Everyone see this little piece right here from O down to the chord? Still counts. All right, just don't think you're going to see a full diameter. All right, as long as it's coming from the center and perpendicular, it knows better. I just had to look at it. Everyone saw that? As long as it's coming from the center, perpendicular to the chord, the theorem applies. Good? That's a huge one we're going to use over and over. All right, here we go. Game face is on. Let's do this. No, this is not a proof. Don't even say a word. No whining. No sighing. It's not a proof. It says statements, reasons. It's not a proof. It's not a proof. Here's what I want to do. I'm going to give you a piece of information. How many true facts can I pull out of you guys now? Now that I threw these new 4 circle facts at you. Read to me. What does this say that I'm giving you right now? What am I telling you is true? 10. What's this telling me?
Arc PR is congruent to arc SU.
Thank you. Now, I know the first question. How do I make arcs congruent? Just put hash marks on them. All right, just put hash marks like their sides. It's fine. So I'm telling you, arc PR is congruent to arc SU. What else is true? Let's go. What else has to be true now? You look back at your facts. Lauren, what's good?
Chord SU equals PR.
Woo! I like the vocab. Chord PR congruent to chord SU. Like it. All right, what if I need this tomorrow in my proof? What am I going to write in the reasons column? What did you know? What was already given to you? What did I give to you already? What was given to you in this one? Oh, 7. What was given? Ready, everybody? Congruent arcs, which I was given. Oh, you know what I'm going to let you do now. What do you think? Yeah, implies What did Lauren just give me? Congruent arcs imply I have congruent chords. Yep. There you go. There's the theorem I want in there. I'm still hungry though. Feed me. Let's go. I'm still hungry. What else is still congruent in this diagram? Come on. Come on, dig deep. What else is still congruent? I got the chords congruent. Yep. What else? Jonah, you got something?
Major arc PR is congruent to major arc SU.
Okay, all right, that's fine. I'm not going to write that, but yes, you are correct. Yes. Avery?
Central angle PQR is congruent to central angle STU.
Angle Q is congruent to angle T. That's the first theorem we went over today. Congruent arcs, which I was given, imply what in this case? And Avery already said it, but I don't know if anybody was listening. 22, congruent arcs imply what are Q and T? Congruent central angles. Beautiful. I'm going to give you one more that I did not provide in the theorems, but this is used constantly in the proofs. Maybe you guys can tell me why it's true. I'm just going to take one of the circles. Why is PQ congruent to QR? Why is that true? Or I could have said ST congruent to TU in the other circle. Jonah?
Because they're both radiuses.
Radiuses. Other than your grammar, that is true. That is true. Everyone agrees. In the same circle, all the radii are congruent. Radii. Yes. Everyone understand that. In a single circle, you draw in all the radii you can. They're all congruent. So in a circle, and yes, I do need that term there. In a circle, all, how do you think you spell it? I'll spot you the R. R-A-D. Double I's. Yep. All radii are congruent. Are you uncomfortable seeing that word up there with the double I's at the end? How about that for a word, huh? Huh? How many would go 0 for 6 on that one? Questions? All right, one more, and then we'll do some algebra ones. Here on this next one, I'm going to give you chord BC and chord KL are congruent. What else is true? Give me something else that must be true. If chord KL and chord BC are equal, what else can you tell me is true? The chords are congruent, so boom. What else? Got something, Paul?
BC arc. BC.
Thank you. Good vocab. Since the chords are congruent, so are their arcs. BC and KL. Based on what we did in problem 1, what do you think's the reason here? Tell me what you're given first. Implies what you wrote down. 24. Good job, Mahmood. Good job. And I'm just realizing right now with this new setup, I broke you guys up, huh? Is the power still there, though? Do you just feed off each other's energy? Okay. One more. Mahmood just gave you the... No, somebody else. Who gave me that? Paul gave you the arcs are congruent. Oh, the arcs are congruent, you say? Serena, what else must be congruent then? Darn right. Angle A congruent to angle J. Now, do I want to start this with congruent chords? No, I don't know. What makes the central angles congruent? Because the arcs, not the chords. So I'm going to start this one off with congruent arcs imply congruent central angles. And then, yes, I could say AB congruent to AC. All the radii are congruent, but we don't need to rewrite all that. Think you'll be ready for a proof tomorrow. Okay, using all these new theorems. Ooh, side, CP, all coming back tomorrow. You're not going to be able to sleep tonight. You'll just be crying yourself to sleep. That makes me so happy. Is that bad? Sorry. You don't have feelings, it doesn't make me feel bad. All right, can you use some of the theorems from today to answer these questions? So there's my diagram in 3. I'm asking for how long is that segment X. Any theorem we went over today, we can apply right now. Any of the 4 right now, we can apply. Does anybody see what's happening in that diagram? Anybody see it? Jonathan?
Chord is being bisected.
Why?
Because
What did I give you in this diagram that you know the chords being? You're correct.
the radius is perpendicular.
Yep. Part of a diameter, part of a radius is perpendicular to the chord we labeled 8. So then the chord's getting what, Jonathan? Bisected. Keep going. What's each piece then on each side? How long? 4 and 4. Good. There's a good start. So because the chord's getting bisected and I know my theorems, that's 4 and 4. All right. Unfortunately, though, no more circle stuff. That's on you now. How do I get the value of X? Little geometry you've been using. Doesn't it seem to creep in every single unit somehow? What am I going to have to use here? Pythagorean Theorem. Yep. Help me fill it in. What value should I place and where? Oh, 1. Meg, where should I plug everything in for? I got X, 4, and 5 to plug into here.
5 squared plus 4 squared.
Oh, 5. What's the 5, though?
Oh, that's not
Where should that go in for?
C.
There we go. And what about on the other side? There we go. X equals 3. Oh, there's a reason explanation box. You're not that good yet. And don't put Pythagorean theorem. I want the circle fact we use. Jonathan, going back to you. Again, how'd you know it was 4 and 4?
Chord was being bisected.
I know that. How'd you know it was being bisected?
Part of a diameter.
Okay, so I'm just going to write a diameter. What was it, Jonathan? A diameter?
Perpendicular to a chord.
Yep, to a chord. Does what?
Bisected.
Thank you. Bisects the chord. There's the theorem I'm looking for. Boom. Okay, good times. Class is almost over. How about 4? 4. How do I find X there? All I gave you was that little piece there with 6. Anything you're adding to the diagram? Anything you can add to the diagram? Matt?
The radii are congruent.
All radii in a circle are congruent. So if that's 6, that's 6. And what are we using to find X again? Pythag or Jonah?
Our 45.
You could use a 45, 45. Yeah! Look at you guys showing off. I love it. Love it. Just trained savages this year. Awesome. Just show up on the darn Regents, please. Oh, can I tell you, second period, I got all fired up because I got 72 equals X squared. Taking the square root, and I'm just ready. I did get all over the kids and be like, what class are we in? We don't leave it in decimal form, simplest radical form. And then a couple of them are like, hey, bud, you did S to the nearest 10. So you got me there. All right, I got to change those directions next year. That makes me so sad inside. If I could. So yeah, I know. Go ahead, type in the calculator. Square root of 72. Oh, 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 oh. That's disgusting. 8.5. 8.5, good. What was the one circle fact we use here, Matt?
Radii are congruent.
In a circle, all radii congruent. And final one to take us home today. Bless you. Final one to take us home. Now, I know most of you could just look at it. Oh, x is 3. Looks like it's 3. But you got to get me there then. You better get me to 3. How? What do you notice about both these chords that I've drawn in? How far away from the center are they? 7 units. So if they're both the same distance from the center, what do I know about the chords? Chords. Here's theorem 1. Chords equidistant from the center are congruent. Got a lot of writing, I know. Sorry. So I know the other chord has to be 6. This chord here is a length of 6 because of that theorem. What's happening to the chord though? Use theorem number 2. What's happening to the chord right now? Come on, finish. 17. What's happening to my chord?
It's being bisected.
Why?
By the diameter.
Diameter is perpendicular to the chord. Bisects it. That's how we get x equals 3. Diameter. Last theorem for today. Diameter perpendicular to a chord bisects the chord. Be ready to put these into your reasons column tomorrow. Get psyched. We are going back to proofs. Good work today. Good work. Especially on the homework today. Good work.